Thanks for coming to my talk. My name is Mike Schilli. I work for Yahoo, and I'm going to talk about round-robin databases, just to set the expectations straight for this talk. This has nothing to do with database failover or round-robin access of traditional databases, but round-robin databases, or RRDs, which are lossy data containers that you use to store data with varying granularity. So I'm going to cover the basics of how RRDs work and how to access them in Perl. I'm going to talk about RRD tool, which is the standard implementation of round-robin databases, and it has a little bit of an arcane syntax. I'm going to show you how to do the same thing in Perl, but with a little bit of a saner syntax. And I'm going to show you some practical examples, some of them pretty non-traditional. So what problem do RRDs solve actually? Basically you have incoming data, like for example what's going on in your network, how many packets are going back and forth, that kind of stuff. And you want to store it in a database, but you don't have space for everything. And you might not be interested in what the network data looked like 10 years ago. You probably are more interested in more recent data. So you have a database with a limited number of slots for the data. You have unlimited data, and so to resolve this obvious conflict, you're going to throw out old data once the new data arrives. That's the round-robin principle there. So if we start at the top, not where the error is, but at where it says start at 1000, we probably get a value of 6.1. This is just an arbitrary value. And then every 5 minutes, there's another value coming in. Now at 120, you have reached the capacity of your database, and you need to figure out what to do next. The solution is obvious. You just throw out the old value that was on top and now replace it by the new one. If you are not satisfied with the number of rows or the number of values that you have in a database, the option is to have two of these round-robin archives. The right one stores the data in 25-minute intervals. The left one is the one from the last slide, which stores it in 5-minute intervals. So although you have a limited number of slots available, now you have high granularity for recent events and lower granularity for past events, which is usually what you want, because it's more interesting to see that there was something wrong with the network an hour ago and you want detailed data on that, while you just want to run statistics on what happened last year. Now, how do you actually get data into RRD tool or an RRD database? There's two components. There is the data source, which is where the data comes from, and the archive, which is the target for the data. The data source takes data from data samples, which arrive at arbitrary intervals. So you don't get a value usually every second or so. You might get a value at the first second, and then there's a pause of 10 seconds, and then there's a pause of 20 seconds. And you consolidate, or RRD tool consolidates the data into primary data points, which is data at a specific points in times. And these primary data points, those end up in the archive, because the archive has data stored in specific intervals. So in order to get around the problem that you get data at non-specific intervals, you go through this consolidation. Here's an example. So the first line shows data samples coming in at various times, and you have a step size in the second line. And whenever there's a step size, there's going to be a primary data point, and RRD tool will just average out the samples that it got over the period of time to make it ready for the archive. Now, there's a second component to the step, and many users who just use RRD tool for the first time get confused about this. So there's also the heartbeat, which is along with the step size, which is the first line. The heartbeat is when you require the data source to deliver data. If you don't get data within that heartbeat, there's something wrong, and you want an error to be reported in the RRD database. The step size is just the time interval in which you want to store data in the database. So these are two different values, and it's important to set them correctly. So if you look on the right-hand side, there's two question marks at the fourth line. And the reason for this is that the red area shows a heartbeat interval where we didn't have a sample. So what RRD tool did was, oops, I don't know what to do, and over the entire step size, it will just write a question mark or an NA, which stands for non-available, into the database. Same thing for this other area. So in this case, the step size, there was no data in the second half of the step, which is the second heartbeat. Therefore, there's also an NA or a question mark in the database. Is that clear or? Excellent.
It looks like there is data.
So there is data in the first half, but we missed the second heartbeat. That's the reason why there's a question mark in there. If you specify the heartbeat to be a certain time interval, you need to have
two
about
heartbeats. One of the heartbeats has data, so why is it question mark when there was some data?
There's a definition of the heartbeat. So it would just extract. It would just freak out if you miss a heartbeat. That's the thing. So it's an implementation thingy. So that's just how RRD tool works. Okay, if you don't want that, then you just put in a slower heartbeat with larger time intervals. So in this case, we have the same samples, but since the heartbeat is now within that heartbeat, let me see if I can do that. Within that heartbeat, we had one sample, although it wasn't in the step size, and now our tool will say, okay, I got a heartbeat, so I'm going to just use the last sample I got for this data point. So long story short, if you're getting confused with the RRD tool's heartbeat, just choose it about twice the sample rate that you usually get. So it can be a little bit off. It will never freak out and put NAs into your database. So for example, if you have a step size of 300, it's 5 minutes, just put the heartbeat to 600. And now, this was the way, how you get from samples to primary data points. How are we getting from primary data points to what actually ends up in the archive? Is that the archive also defines a certain step size. As I showed previously, there were these two archives with different granularity. So that's the step size of the archive. And how the data gets from the primary data point into the archive is defined by a so-called consolidation function, which can be something like average or the max or the minimum or something like this. There's also an Xfile factor which is probably something that you don't want to use right away, but it allows you to skip over some undefined values. If you get undefined values in your primary data points, there's ways to smooth that out with the Xfile factor. Here's another graph on how this works. That's like a top-level picture. So you have the samples on top, you have the primary data points, and you have 3 different archives with different step sizes. The third line, for example, has an archive which has only 5 data points, and it will roll over, while the lower ones have 10 different data points, and they're not really displayed on this graph. So let's put in a quick example. Let's say I have a web application and I have 100 orders at point 0, and at 1 o'clock I have 110 orders. These are just arbitrary numbers, and I want to graph them. This is the major reason why I want to use RD to store and to graph data. And I want to get something like this out of it, right? Without too much effort. But I have a graph with some legend, and put in one or more graphs in a certain color. So if you use RD tool in order to do that, it looks kind of crazy, because for every call to RD tool, you need to call this command line feature. And the syntax is kind of arcane, because you have to remember that the parameters are in a certain order, and then you define your data sources, and from the graph you need to reference this data source again. So it kind of gets tedious if you write that by hand. So there's a rds.pm module that comes with the RD tool distribution. But basically what it does is just it provides a Perlish syntax for these calls. You still need to remember the parameter order and stuff like that. So this is not really useful. What I came up with is a module on CPAN that's called RD tool ::00 for something like object oriented, and it provides a little bit of a better and more convenient syntax. It looks a little bit more Perlish than what you saw previously. It translates between Perl and RD. It calls RD tool under the hood, but you're not exposed to this arcane syntax. And of course, it uses named parameters instead of ordering them in a certain way. So if I want to create a new RD database from scratch, I just call the constructor and call the create method, which I hand the step size to, which is 1 hour, which means that I need to feed it the data on an hourly basis. I'm also going to provide a start time. So you could certainly do that with the time call and using the epoch seconds, but I kind of got used to using the DateTime module to do that. It's kind of overkill in this case, but I'm so used to DateTime because I think this is just the perfect module for times. You never need to think about whether it's going to do something wrong or whether you have a leap year or something like this. It's all taken care of. Wonderful module by Dave Rolski. And in this example, I just create 2 different time instances. One is the start time, which is basically today. And I also create another DateTime object, which I use to advance the pointer by 1 hour for each call. You could do the same thing by using time and adding 3,600 each time. It's just not as clean, I guess. So in order to feed the data into the RD database, we call the update method, which takes a time when it happens, and also a value, which is just 100 by hour by 10, because we have this data series that goes 100, 110, 120, and so forth. If you leave out the time, then it will just use the current time. You use this if you're graphing the data as it comes in. You don't need to specify the time, but if you abuse RD tool to graph stuff that's happened previously, or just to graph something with arbitrary times, they need to provide the timestamp. And in order to graph the data that you just pumped in, you call the graph method. You provide an output image, usually PNG. I think JPEG works as well. And what you want to put at the vertical label, what the start time is, what the end time is, and then the type of graph. As you've seen, these were like area graph, the color, which is blue, RGB, so FF for blue, and web orders is the legend, and this is it. This was all the code that was necessary to generate this graph. I use this all the time when I'm too lazy to use Imager, Plot, or any of these other modules, because they require me to figure out, well, what would I really put on the x-axis? Are these hours or are these seconds? And our detail is so flexible. If you pump in the data by the month or so, it would just write the months on the x-axis. So it's fairly automatic. That's what I like about it. Any questions so far? And okay, so these are the commands that were necessary to do that, but the module generated this under the hood for you. Okay, let's talk about that as well. So the problem with our detail is that it's really designed to process data as it comes in. So it gets totally confused if you pump in data for previous events, because that doesn't happen usually, right? So what you need to do, if you're graphing data that happened previously, you need to make sure that you pump that in consecutively, not randomly. And you also can't put in data twice for one time. So you'll get an error back from our detail. This is kind of annoying, but I guess it's how our detail is implemented, because it's around our archives. It makes it easier if you put in the data subsequently. Okay, well, a couple of things so that so our detail doesn't get you tripped up. Feed in the data by the timestamp. Never put anything in before the start time. That'll also create an error. And updates in increasing timestamps, that's right. And so I stumbled across one thing. If you have large step sizes, 1 year, so our D2 isn't really designed to handle that kind of step size. Because if you, let's say you have a step size of 1 year, and then you put in an RD archive that handles 50 different slots, all of a sudden you end up in the year 2058, which causes problems on the Unix systems. So that's not going to work well. And I actually managed to crash RD tool with that one. If you want RD to log something, it's log for Perl enabled, so, which means that the program I just showed you, you just put that on top of the program, and all of a sudden it will start logging what it does, and it will actually spit out what kind of commands it will issue, and it will also tell you where something really goes wrong. Sometimes if you get an error back, you really need to know what RD tool under the hood gave you back. So this is a fun application that I did to use RD tool in a non-traditional way. This is a stock portfolio with 4 different stocks and a cache. position over the course of 1 year. So you can actually figure out not only what the bottom line is, how much your portfolio is worth, but also how it changed, how the positions changed over time. So I've never found anything like that on one of the major finance sites, but I think it's quite important that you know how your different positions performed over time. And RD tool is perfect at that. You just need to make sure that you feed in the data consecutively, day by day, and you can get the historical data from Yahoo or Google Finance sites for free. This is another application that I did. So I wanted to know how much power does my desktop at home consume, because I wanted to save on electricity. And I soldered some cables into my power strip. I'm not recommending that you do that if you're not comfortable with it, or if you set your house on fire, don't sue me. But basically the data I got out of this instrument looked like this. This is the number of amperes, and if you multiply it by the voltage, you probably get the power usage. It's not accurate, but you get an idea on what's going on. So this is my desktop, which runs 24 hours a day. And at 2 o'clock in the morning, there's a backup job running, so it accesses the hard drive, and then all of a sudden the usage gets up. It's kind of interesting to watch that grow. This is my laptop, and when you switch it on, and it bumps up to 200 milliamperes, and it flattens out as it calms down. And this is another fun way, or actually quite a useful way to use RD tool. It allows you to track aberrant behavior. So if you have data coming in, and it actually has a certain baseline, and it also has a certain slope, and also it has some seasonal components. Like, for example, if you run a CVS or SVN system, you might notice that right before lunchtime, it always hits a peak, because people go to lunch and they want to check in stuff so that it doesn't get lost. If you have these seasonal components, you want a system that doesn't get tripped up by these, but only reports things that are truly errors. And it's kind of a science to figure out what is really an error, and what is a seasonal component, and what is the slope. So our detail has a way to define these components and to trigger an error when something goes wrong. So you see that the red line actually shows where our D2 thought that there was an error. So that was it. These are the references about the things I talked about. There's a couple of articles on RD tool usage. Any questions on what I've talked about? If not, thanks for listening.